Hello, I'm Ian Clester. My co-author is Jason Freeman, and I'm at Georgia Tech. I'm here to talk to you about Alternator, a general purpose generative music player. So the first thing I need to do is tell you what I mean by generative music. Brian gave a really interesting presentation before lunch that I think pretty much covered what I want to describe in the introduction. So I may not spend as much time there. But to begin, I'll start with this quote by Brian Eno, who wrote a classic essay about generative music, laying out these three alternatives. So live music, where it's different every time by its very nature, but also has a particular time and place where it happens. Recorded music, where it's identical every time, but is very convenient. You can listen to it whenever you want. And then generative music, which has both of these aspects. And so that's what I'm going to be discussing today. So that historically, we have this goal with recording technology, right? Where you want to perfectly reproduce something, right? So here's a vintage advertisement where the Edison concert phonograph perfectly reproduces the human voice. In just the way that it was the first time. But of course, a real human voice, sounds a bit different every time it's used. And so that, but through different mediums, the phonograph, this is so old, it's still a cylinder instead of a disc. But through magnetic tape, through CDs, that's always been the goal, perfect reproduction. But then on the other hand, we have these generative machines, right? Where this thing can compute a process, can generate an outcome that can depend on external input, perhaps depend on chance. And nowadays, everyone has a smartphone, certainly here, and probably you do a fair amount of your personal listening on that device, but you're still using it to listen to static audio, probably streamed from Spotify or SoundCloud or whatever service. So why are these two things so disparate? Why are they separate? So first, I'm going to talk about these tools for creating generative music. So there's this program Cone from back in the day, which was specifically intended for making generative music. And it gave you this graphical interface. And nowadays, there's, it has a lineage where Intermorphic now makes a product that's a successor to this, so that's still around. But then also, we have all these other tools, which are more maybe synthesis-oriented, but can also be used for making generative music, right? So Pure Data, Max, Csound, all of these great things. And of course, general-purpose languages too, you can use to describe a piece of generative music where you have a program or a patch, you run it, it makes audio. The audio can be different every time it runs. But these tools don't really address the issue of distribution. It's not so convenient if I email you a Max patch and say, okay, here's the music. It's really awesome. I promise. Please install Max MSP. Max in particular lets you export to an exe that includes the Max runtime, I believe. But that's still not great because then I'm saying, here's an exe. Please trust me a lot and just run this on your machine. Also not ideal. So there's this barrier to actually distributing generative music and having it heard by listeners. So people have taken different approaches to this before. One option is server-side rendering. So Jason Freeman, my co-author, did an album of pieces written in a language called RTcmix, the Grow Old EP. And the idea is that the pieces grow old with you. So the pieces age, they sound different every day, and they're just regenerated by a server and then re-uploaded. So that works for that piece because just rendering it once every day is fine. And then there's generative radio stations like Rand, or more recently Stream, which can play generative. on the server per listener concurrently. And that would be, I think, very difficult to scale. You know, if you have 1,000 listeners, you don't want to be running 1,000 programs and 1,000 sandboxes and then streaming audio to all of them. That's different. So some projects instead do client-side rendering. So these apps that you might have for generative music, like Bloom, work this way, where you install an application on your phone that synthesizes audio, and then you don't have to worry about a server somewhere doing all this. And also Generative.fm by Alex Boehner does this really well using web audio and Tone.js. So you can go there, listen to all these different pieces that Alex has composed, and you know the server does not need to do much more than just serve that JavaScript. And so that works really well for that. And then there's also apps for specific languages. So you can run pure data patches on your Android device, that kind of thing. And then also there's perhaps the most interesting thing historically, MPEG-4 structured audio, where this made it into the MPEG standard and then didn't really see much adoption or much implementation. And my take on this, sort of the Alternator position, is that this is because it was too specific and too high level. So with MPEG-4 structured audio, or even with, if you say, oh, just go use Tone.js, you're saying you have to use this specific language, and you have to have a specific way of composing. And in the MPEG-4 structured audio case, that was a language very similar to Csound. But if you have a piece that you didn't write in Csound, then you probably don't want to try to port it. So that's another obstacle. So the Alternator proposal is, don't record music as a fixed sequence of audio samples. Don't require composers to use the one chosen language. And don't require listeners to install a player application or run untrusted executables. These are all substantial barriers. But this slide composers many languages, frameworks, and ways of working. And you can accomplish that by adopting a sufficiently low-level representation. Maybe you can guess where I'm going with this. And then also allow listeners to listen on any device that can run a modern web browser using a familiar interface. So give listeners the things that they expect: play, pause, volume control, basic things, and don't surprise them by making them learn a new interface for every piece. So for composers, you create generative music using your preferred tools, publish a bundle, including that code and any assets necessary. Listeners play music in the Alternator player, which fetches and executes the generative bundles. And then the track can be different every time it's played. So what is this generative bundle that I'm referring to? So in Alternator, it's a WebAssembly blob. So that's the low-level representation. That's very convenient. And then some JS glue code, unfortunately. And then static assets. So if your composition requires a WAV file, a MIDI file, a trained machine learning model, whatever, then you can bundle that with the code. So an important goal here is, one is generality, which I've sort of been talking about, and the other is stability. So for now, Alternator has an extremely simple interface for bundles because I don't want to break it later. I don't want to say, oh, your piece worked a month ago, but now I've made some API changes and suddenly your music is broken. That is not good. And so I don't want to do that. So right now the interface just has two functions: setup, where the piece gets told what sample rate it's going to be running at, and it can return a promise if it needs to load some stuff in. And then process, which just fills a buffer and then says, basically either I filled the buffer or I only partly filled the buffer because the piece is over. And then here's a really trivial example, just in JavaScript without any WebAssembly, of what that might look like. So this just picks a random frequency and then plays that tone forever. And this is something you could other language. So for instance, with pure data, you can use the bundle template, save your thing as main.pd, and when you run the bundle tool, it'll use the template, bundle it with the WebAssembly that contains libpd, and you're good to go. And here's some other bundle templates that are already supported, and including, if you want, static audio. So you can do that too. It's strictly a superset of what you can do on existing platforms. And then also you can use compiled languages directly, like C or Rust. The process is a little bit different though, because then you are generating the WebAssembly. There's no bundle that already has it. So here's a quick example of what that looks like from the composer's perspective. So I have my amazing pure data patch. This does not do anything terribly exciting, but it makes some audio. Then I say, okay, what is this? It's a track on an album. It has perhaps a certain duration. If you leave that out, then the duration is assumed to be infinite, since generated pieces can be infinite. And just specify this metadata, and then you bundle it up with the bundle tool. It spits out some information for you. And then optionally, you can distribute this. So right now, you can use Alternator. I'll give you the link in a minute. And it will look on GitHub for repositories with the Alternator album tag. And any that it finds, it will show in the interface, and then you can play tracks from there. So right now, effectively, GitHub is being used for the hosting. But you can also self-host an album and distribute a link with that self-hosted URL if you want to. So, and then for the listener, we're trying to provide something that's intelligible based on how people already listen to music, but also exposes generative aspects. So we'll see in a demo in a second, but there's a seek bar, and then there's this thing where, infinite tracks. So here's the link. I'm just going to run this locally because I'm not sure about the internet, but let's see. Okay, so if we go back to the start, it looks something like this. So the albums, you click an album, you get tracks, nothing groundbreaking from an interface perspective. But then if you play something, I'll turn that down because it's a little piercing. This is trivial tone. It will go on forever if you let it, but you can pause it, you can play it, you can go backwards, you can skip ahead. If you reset it, different tone. Here's a slightly more musical example, warm up. So if we reset, it'll do a different little tune. And then it just keeps repeating it, transposing it up, going faster. So I'm seeking ahead. Okay, and if you click this button, then you can see the source. So this one is entirely in JavaScript. You can see go look at how it works. Generators are cool, would recommend. And then here's like an example in pure data. If you look at the source, well, it's a pure data patch, so this is what it looks like as text. But then if you play one of these other examples, like this one.
0, 1, 1. 0, 1, 1.
So this one is written in Rust. So if you go look at this, you don't see the Rust. You see the JS glue code. But you can click view in, well, I'm doing it offline, so that this does not work. But if you go to that link and do this, it'll take you to GitHub, and then you can go find the actual source code of the Rust. And this also has samples included, which is another thing you can do. Okay. It'll be interesting also to see what the practices are around this in terms of sharing code. I mean, right now it's pretty rare for artists to release their stems or much less release DAW projects. But at least in programming, there's a strong open source ethos. So that's one thing I'm interested in, is what that culture will be like. Another thing here, Alternator right now, purely generative music, not interactive music. And that's mostly for the simplicity of the interface. So I don't want to give you a cool interactive music thing and then have to take it away later because it's like terrible on mobile or something. There's a lot of JS glue code. I want there not to be. So I'm very excited about the prospect of not having that. But also this means right now, like the JS glue code, it runs in a web worker, but still it can do all these crazy things like, just go fetch stuff. Someone unscrupulous could, sneak a crypto miner into your little song. Please don't. And also I just want to say, it's really an interesting time. I mean, you all know this, but this Alternator and something like Alternator is possible now because of this amazing confluence of things, which many of you have contributed to, right? So all of these bundle templates, a lot of them build on existing work by people to get their audio programming languages to work on the web. And then Alternator itself, of course, uses web workers and AudioWorklets and WebAssembly and all these things. And it's just really amazing that this is feasible now. And I can just give you a link and voila. So in the future, some clear next steps. I want to be able to share, have users share seeds that they find and like. So if you hear a particular version of a generative composition, you're like, whoa, that's really interesting, then you should be able to share that with someone else and say, oh, look what I found. Alternator bundle player. And then, of course, another big area here is tooling. So right now, you have to run some scripts. You have to already know one of these audio programming languages. And these are, of course, barriers to a lot of composers. And so I'm very interested in finding ways to bring generativity to composers, to say, OK, you have a way of working already. You know how to use a DAW. How can I give you tools that let you make generative bundles without learning a whole separate world? And I think that's about it. So thank you for listening, and I'd love to take questions.
Thank you very much, Ian. So are there any questions in the room? Yeah.
Thank you. Hello. I was wondering if you've thought about how the design of incorporating interaction would work, like how you could make a generative model a generative design that everyone can customize their own interface.
Yeah, it's a good question. I mean, there's a million ways you could bring in interactivity. I could just throw a canvas there instead of the album cover image and then say, oh, if the composition wants to listen to touch events, then it can. But then the API gets more complex. A lot of compositions won't care. So I think it's something that I have to be thoughtful about if I am committing to anything. So I think, yeah, one thing I definitely want to do is some experiments in this regard and say, OK, here's an experimental interactive music interface that gives you more input for the composition, for the bundle. But that'll come with the caveat that this might change. We might break your composition, and then you'll be sad. Because that's a risk with this in general. Is it's music, but it's also software, and software breaks, right? Like APIs change, your stuff doesn't work anymore. You have to maintain it in an ongoing way. Whereas with music, once you have a WAV file, you put that on SoundCloud or Spotify. There's no reason for that to need to change. It's just PCM data. That's what maintenance could be required. So that's a sort of hazard that I'm very cognizant of with this project.
Any other questions? We have time for another one. Yeah.
Hey, so obviously awesome work, really exciting and super inspiring. I was curious, I know you're running this offline, but do you have any examples that are synchronized with a pre-recorded WAV file?
Yeah. So I can try pulling up the online one. We'll see how it goes. Yeah, it looks like it's working.
And also, of course, curious what the process was like in terms of pre-recording the audio and then implementing the generative aspect.
Yeah. So all these examples so far, except for the ones I've imported, like John Chowning's Straya and Csound, most of these examples are sort of very demo-y. But yeah, the Rust one I showed includes WAV files using a Rust thing that embeds the data directly in the executable. There's a Rust macro for that, but most of these, like this one, it'll take a minute to load probably. This loads the entire Python interpreter first, and then starts generating audio using Python and WebAssembly. So it'll be a second. But this one has a bunch of like drum samples, and then those are played in a particular way. I have no idea how fast or slow the connection is. Oh, there we go. Okay, great. So it picks a random tempo. It does random accents. We got pretty slow tempo this time. But yeah, if you go look at the source, then there's like the main thing. There's a bunch of library code, which I'm pulling in, and then there's just WAV files. And the actual source code for this is really short, right? Because it's using this composition library. But this is like using audio samples. So these are kicks, these are snares, these are hats, and then it's also doing a generative thing here with the accents and also with the BPM. Yeah, so I want it to be easy to pull in assets and work with those.
Yeah, great. Thanks for the demo, and you can continue the conversation later on. So let's give another round of applause to Ian and Jason Freeman. Thanks.